Welcome to session AH, integrating Mainframe and AWS with Ansible in the DevOps pipeline. Bill Pereira returns after his session earlier today, along with Gilberto. They're going to co-host this session. So questions, how do you want to handle those, Gilberto and Bill, as you go or at the end?
It can be as we go.
Okay, so I'll monitor the chat and I will mute myself. So you guys feel free to start whenever you're ready. Thank you.
Okay, thanks. So hello everyone. Let's start presenting ourselves. So if you don't know me yet, I'm Bill Pereira. I've been working with Mainframe for a bit more of 13 years. The last 4 years focusing more on integrating on DevOps, Zoe, Ansible area. And today I'm here with Gilberto. So Gilberto, you can present also.
Hello, everyone. I'm Gilberto Biondo. I'm a specialist solutions architect at AWS, focusing on mainframe workloads. Okay, so just to give you a little background on myself, I have about 15 years or so with mainframe experience, ranging all the way from operations to system architecture, including mainframe upgrades, consolidation, modernization projects. Okay, and today we're going to discuss a bit about integrating mainframe with the DevOps pipelines. All right. Okay. Yeah. Okay, so let's start here with a little agenda on what we'll be talking here today. Okay, so the first topic is why should I change the way I deploy my applications, right? We know that mainframes have been out for 40 years, 50 years, and the process that has been done is great and it works, right? So why should I change, or why do business or applications want to change the way they deploy their code? Okay, we'll follow by the DevOps approach. Okay, what it is, what it's not, and what are the key differences between what is known as a waterfall deployment type and a DevOps operation time. Followed by creating a basic DevOps environment for mainframe workloads. Okay, this is where we're going to discuss the basic architecture, where we talk about the mainframe and cloud integration for a hybrid workload. And we will finalize with a demo, okay, where we put everything that we discussed in practice. And that will also be open for questions and answer. Well, we plan to leave a few minutes in the end to answer any additional questions that may you all may have. Okay, if you have any other questions as well, feel free to put in the chat and we'll try to answer them as we go along. And if we don't have time, or if we don't see that on time, we try to answer that at the end of the this agenda. All right. Okay, yeah, so let's start here talking about why should I change the way I deploy my applications, right? And I bring here some words or phrase that we usually hear when we're talking about mainframe and adding new stuff to mainframe, right? So something like, okay, but it has always worked this way, you know, if it ain't broke, don't fix it, or, you know, it's just as good as it is right now. So these are some of the phrases that we used to hear when we talk about bringing some agility or bringing new activities to a mainframe workload. Okay, and we would like to understand here why to do that. Okay, and the main reason here is because the business require agility. Okay, so we've seen, especially with the last 2 years, with the digitalization of the environments and with the pandemics and everyone working from home, that digital services just exploded, and the amount of innovation and new apps and new companies and everything just exploded, right? So the business require agility. right? So they cannot, they can no longer wait for 1 month or 3 months to deploy a new release or deploy a new functionality to their environment. Okay, and just to give you one idea here, there is a study that we got this data from that states that over 50% or over half the organizations take between 1 and 3 months to deliver a release. Okay, so over half of all the companies in the market, they take more than a month to deliver this release, especially even if it's a core application or if it's a core patch. Usually either they take this long or they skip some important process like testing their application or doing homologation phase or doing extended test. Okay, so that can result in a low code or problems with your code or low code quality. Okay, so this is one of the main reasons why business want to increase the agility and why we're talking about using DevOps with the mainframes, right? Bill, anything you'd like to add here?
Yeah, this is really important, and I think this is what I've mentioned to everyone. So we see every day we need more flexibility when we are delivering things. So we see the companies are starting to implement new features to fix what is available, and they are doing this every time faster. And the reason is because they have how to do that. They have a way where they can test, ensure, and bring these features. And the interesting thing here is that what we are going to show is that all that they are using, we can also make advantage of that. Yesterday, I was in another call in a presentation, and it was really about that. We were doing in a meeting in my team, and we were discussing, okay, how we take these tools on the DevOps, how we take the best from the DevOps and adapt, integrate with our way. It's not like we are replacing the way you were doing the deployment, but this is taking these tools and making the advantage of them.
Mm-hmm. Exactly. I think, Bill, you just mentioned a very important thing here, that it's not a rip and replace. Okay, so we're not just scratching everything we've done over the last 40 years and applying something new. Okay, so it's just adapting and just taking advantage of everything that's good and that we can improve our services. Okay, and that goes along with the some other metrics that we have. Okay, so just to give you one idea here, that the average annual labor cost for time spent with CI/CD, manual CI/CD tasks is over $7 million per company. Okay, so it's just saying here that some companies can spend up to 30% of their time with CI/CD related tasks. Okay, and when we say that, we can include like provisioning an environment, doing testing code, deploying code, assessing the results of my tests. Okay, so these are all tasks that are usually done manually. Okay, that can be done automatically or that can be done in a more modern way, and that would reduce a large sum for the company, and that would also means that you're not as overloaded. Okay, so you release your time to focus on other things that are important. Okay, so instead of spending your time deploying new data sets and deploying and APFing data sets for a new application and coding some basic ZOFs activities, right? You can focus on learning new components, or you can focus on applying new techniques or applying something new, so you can even improve yourself as well. Okay, and along with that, and with this information, over 62% of the DevOps leaders are investing in automating the CI/CD tasks. Okay, so this comes along with this idea of deploying or automating those CI/CD tasks that we'll be discussing. Okay, so the idea with DevOps is basically just automating these and focusing on deploying your code or coding, making sure you have time to code and to do really good quality software, and also allow the infrastructure folks and support folks to focus on their main business instead of having to do manual tasks on a daily basis, right? So, Bill, anything here?
No, go ahead.
Okay, very good. So let's talk a bit about the DevOps approach, okay? So some things are that we usually hear when we talk about the DevOps approach, right, is, oh, I already have my code handy, right? I already have my code in my data set and I have access to that, or my application is too critical for deploying that through a DevOps because, you know, I'm changing code, someone else is changing code, and that may be harmful or dangerous for my application, okay? That's something we usually hear when we talk about DevOps approach, okay? But we have to remember here that when we talk about the DevOps, we're actually trying to reduce the gap between the developers and the operations members, okay? Usually when you're talking about a siloed environment and a waterfall environment, project environment, where you have your project phase and you start developing, you start testing, and then you release your code, that can take several months, and that requires a lot of organization between different teams. So that adds complexity, that adds time to your deployment, right? When you're talking about the DevOps, you're reducing this gap. You're allowing that the developers and the operations team, the infrastructure and support teams can work together and can work as a team to increase the collaboration and provide a better communication. Okay, so you will have a single team that is responsible for both deploying the environment, testing the environment, deploying the infrastructure, checking the code, assessing the test results, and deploying and operating that on the other end. Okay, so instead of having a siloed environment, you have, like we used to hear in the market, like a two-pizza team, where you have a bunch of people. Some of them have development skills, some of them have infrastructure skills, some of them have support skills, and they all work together and they all work as a team so they can deploy the applications faster. Okay, so if I'm a developer and I'm in a team with other people that have other skills, I can just go with them and say, hey, we're trying to develop something here, and we'll need some data set here. We will need a new high-level qualifier. I will need some libraries to be APF authorized. I'll need some new user IDs, and I'll need something else, right? That can be worked much faster with a DevOps approach. I have already the team and the resources I need on my team to be able to deploy that, okay? And instead of having to manually go through my 3270 screen and say, hey, deploy, let's create this data set 3.2, allocate a new data set, and doing something like that, issuing comments to APF authorize one data set, I can simply create scripts, right? That will do that for me. That's what we try to do, and that's what we've been doing with Ansible, with the DevOps, with the pipelines, with deploys and builds, right? So you can just create this new environment or this new script and allow the team or allow the developers to use those scripts to create what they need, right? So instead of having a developer or an application person going to you on a daily or a weekly basis, hey, I need a new data set, I need a new authorization, or I need something else, you can just develop your script and say, here, hey, here, take this one. So you're authorized to run this script. So this script will allocate a new data set. This other script will APF authorize one library, this one will do a backup, this one will do RACF authorization, this one will do something else, and then the developers can work with those scripts and don't have to bug you every time they need, okay? And that releases you, that frees you time so you can focus on adding new functionalities, on learning new capabilities, either on mainframe or on the cloud, whatever you're interested, and you can deploy even better, right? So you can try to take advantage of other stuff as well. You're not overwhelmed by the fact that you have to deploy something for yesterday that someone just asked you today, right? And that brings us the topics that we discuss here, you know, the automation, the development simplification, code quality, okay, because you're focusing on deploying your code or coding your application instead of having to bug someone else for something you need, and that also unites your teams for a faster production shipments. Okay, so there's another study that says that you can achieve up to like a 50 or 60% increase or reduction on your delivery time when you start deploying those DevOps concepts. Okay.
Yeah, it's important also to mention that even that we are talking and focusing this session on the application, this also brings the advantages for the infrastructure side. So the same way you are doing these steps for them, you are implementing them on scripting, on your playbooks, everything. As you are gaining maturity, that is also enabling you to expose it even more for your support process. So when you have to implement, install new things, give maintenance, you can also take advantage of that. Putting the tasks you are doing, mapping your infrastructure as code, so you are being able to have the tasks you would be doing in the evening, during out of the business hours, you are able to gain maturity, map them, have them automated. So a lot of other opportunities starts to happen on your environment.
Exactly. And thank you very much, Bill, because that just reminds me, you know, that I've been in storage support for a very long time. Like I think I spent like 10 years or so, or 8 years with storage support. And it was really, really common to have people to come to me and say, hey, I will need a new alias for my application, or I need a backup for my application, or I need to restore one specific backup from my application, or I have my maintenance tasks that I have to do on a monthly basis, like I have a catalog reorg, or I have some change to my SMS code, or I have to provide some reports to management teams, right? Everything that we're talking here can be automated and can be made simpler by creating scripts like this. Okay, so as Bill mentioned, I could have created a script, right, where the user says, hey, I want to back up everything that's under this high-level qualifier or this specific data set. And that could trigger a process that will create everything I need and deploy that to my code. So I don't have to manually go to my code, do some script change or do some SMS updates, test that, and then deploy. Everything could be done automatically. Okay, so you can even write, or you can even update or add your SMS constructs. You could create a new SMS construct. You could run some tests with that using the Ansible playbooks that will be seen soon, and then you just deploy to your test environment and to your production environment, and you don't have to spend a long time or spend a weekend doing that because you don't want to, or you cannot do that during business hours. Okay, that's the same for catalog reorgs, right? I could do a script and have everything done automatically, right? And I'm sure, Bill, you remember anything? I know we've talked about a few stuff that you've done that automated very much ZOS activities as well. You want to mention something?
Yeah. So a lot of activities. Now we have all kind of integration with Ansible. We are integrating different environments. For example, in the certificate management area, we are having one process that is doing all the installation in Redcaf, in Data Power, in the cloud. And at the same time, we are starting with these small steps, like you mentioned. So some of these activities we do on the support, they don't really aggregate a lot for us. Sometimes they don't have this right risk. They are just something that you are doing really manually, and we are just importing them. At the same time, when you start integrating these Ansible scripts, you can have them running like we are doing here in the pipeline. You can have them running in other platforms, and these pipelines, the Ansible automation platform, they will also have the APIs to be called. So as you started with these baby steps, you start having a much bigger set of tools that you can use. And in the future, you can start also triggering that with a ticket or with a change management system. So everything can integrate.
Exactly, and that's very important as you mentioned it. If you have a single system where you have to work, okay, you may have to do that once. But if you have 10 LPARs, or if you have 50 LPARs or 100 LPARs, you may have to do that 100 times. So the scale that you gain when you automate things may be exponentially good, right? So you can take a lot of advantage from doing that, right? Okay, so let's go with the creating a basic DevOps environment for a mainframe workload, okay? And usually some things that we hear when we talk about this one, it says, okay, oh, well, it actually will only result in more work to me, because I'll have a pipeline or I'll have something that I have to handle, right? And also, oh, developers will always over provision, right? Oh, they will always ask for everything they can, and we have to control that, okay? But we'll talk here about a couple of these topics and how you can prevent that, okay? So just to give you one idea here, this is the basic DevOps environment that we'll be doing for a mainframe workload, okay? And I'll explain here with Bill on what we're doing and what are the steps, and then we'll see that working on a live environment, okay? But very important to say, right, is that although you do have the automation and you do have the capability of allowing developers to provision what they want, you can also restrict what they can do, okay? So it's not a all or nothing situation, right? So, okay, I want to allow my developer to provision over up to, 100 policies or 2 different applications or something specific, or some CPU consumption policy. I want to limit that. You can do so, right? It's not a situation where, okay, I'm giving you the keys to my home and you do everything you want, okay? You can impose a limit. So that's very important and very nice to know, that you can work together and you can restrict, or you can cherry pick on what's being allowed or denied to be deployed with your infrastructure, right? So going over here to the architecture that we're going to do, okay? We have what we've done, okay? We have created a pipeline here, okay? This pipeline here is already created, okay? And it's waiting on AWS Cloud, okay? It's just sitting there. It's not doing anything. It's not consuming any resources, okay? And what it does, it checks for one S3 bucket, right? Which is the object storage from AWS. It checks for one S3 bucket here for a file called params.zip. Okay, so I have a set of parameters that I can set up. Okay, like, okay, I want to deploy one new application here. My new application will be called this, and it will have one repository here. It will have something different here and there. Okay, and once I push these parameters here to my bucket, it will trigger an event that will kick off my pipeline. Okay, when I kick off this pipeline, it will build my infrastructure here and will create a stack, okay, with all the resources that my application will need. Okay, so what are the resources that will be created? Okay, I will create here another pipeline that will be specific for that application. Okay, so each application I create will have its own pipeline, so I don't have different applications coming together and messing with each other. Okay, and this pipeline will have a code repository here. So we're using AWS Code Commit to store all my COBOL, BMS, copybooks, JCL, procs, everything I'll be storing here in my code commit. Okay, I will also have a code build here that will take all this source data that was stored here and will compile, will do some tests, it can do syntax check, you can create different scripts. So, hey, I want to enforce some naming convention. You can do that, and you can create that in your deployment and your build here. Okay, in this specific case, we're going to build that or to compile the COBOL code to be tested on both AWS Cloud and on the mainframe. Okay, so it will compile your COBOL code, and then it will go to the code deploy here. Okay, so what the code deploy does, it deploys the code that was built, okay, and it will deploy the code to two different environments. Okay, it will deploy here for an environment, which is the AWS mainframe modernization. Okay, this one is running the AWS mainframe modernization service replatform option. So it's actually running an environment that can run your COBOL code. Okay, so you can use this environment for your development, for your test, for your system integration, you know, so you can release some MIPS and you can release some computing space that's currently being used in your mainframe environment that shares production, test, and development environments. You can run that on as needed basis on the mainframe modernization from AWS, and you can also deploy at the same time or at a later stage if you want, right? Using the Ansible playbook to your actual mainframe. Okay, so just to give you one idea here, if I want to go further with my application here, I could add an actual extra step here. So I could do my coding here and build my code, deploy my code to AWS mainframe modernization, test it, make sure I don't have any bugs, my code tests well, you know, the outputs are expected. And once I'm sure the code quality is good, I'm not having any bugs or anything, I can add an extra step saying, hey, my test is good. I have a manual approval, or I have some other trigger events that will be used for the Ansible playbook here to deploy the code to the mainframe. All right, Bill, anything here?
Yeah. So one of the nice things about this is you were creating the way, the thing that will keep you safe when you are doing your deployments, because it's not just, okay, we need to go quicker with what we are delivering, but you need to ensure that everything will work. So with this way, you were able to have a structure that will help you, that will support you during the tests. So like Gilberto said, during this process, we have a set of tests that will run against your COBOL code, against your all of the the testings you need to ensure that it's running. Other important thing, you are creating, I see this also with some in my environment also, sometimes it's a bit overloaded with, okay, how I'm going to create this pipeline, how can I transfer this code, test it, what is needed for my pipeline. So when we are creating this structure, this deploy infrastructure, also this first pipeline, we are also delivering for the people who gonna be working with this application all the structure that they need. So they don't need to worry about, okay, what's the setup needed for the code commit or for the pipeline. Everything will be ready. You would be able to replicate this infrastructure with other application teams on your environment, so you can replicate as many times as you want, and they will always have what they need. So the Ansible will be there to do this integration with the mainframe also, so they don't need to worry, okay, how I'm going to deploy this, how can I send the code, or do I need to handle the encoding before doing that? No, because everything it's ready, it's prepared, the infrastructure is configured. You don't need to worry about that. You just need to think, okay, what are the steps that this specific application need, and this is just the customization you're going to be doing. So you go to your playbook, you change what are the steps. For example, here is a simple step. We are just ensuring some data sets exist. We are going to upload all the code that is coming from the code commit. So every time you are doing updates on your environment, on your code, the pipeline will run again, will bring this code back to the mainframe. So we will execute the tests before on this test instance, and then we'll go to your real part. So you are having this the safety, this standard process, and you are being able to map all that's needed inside of Ansible with your playbook. If you need in the future to do some actions, you can use Ansible for other integration. Also, it's something that's not just used for the mainframe, but you can use with network devices, with any configuration, MCMDB, everything, and it will be there for you, just waiting. You just need to map what you need to do. If you need to run commands, if you need to do something with kicks, with USMF, anything, you're gonna have the support to run through the Ansible, through this SSH connection that we are going to have with the LPAR.
Exactly. I think one of the key words that we have here is reuse, right? Because once we create this first pipeline that deploys the automation we want, I have created that once. If I want to have 100 different applications, this code would still be the same. I wouldn't have to change anything. It's just the configuration file here that the user or the developer changes, and they say, hey, this is what I want to create, and it will create for you. Okay, and if I don't want that anymore, if my application has been sunset, or it has been replaced by another application, or has been merged, or whatever, right, I can just come here and delete my stack, and that will destroy the infrastructure on the cloud here, so you don't have to worry about consuming resources that you don't require on the cloud either. Okay, so that's very important.
Yeah, we are getting a new hat. We are becoming YML engineers. Yeah,
exactly. So I think we're done with the talking, right? Let's go to the fun stuff, right? So let's go to the demo side. Let me stop here and come here to my AWS console. Okay, so what we're going to do here, okay, I'll just upload a new params here, okay, because it takes a few minutes to run all the pipelines and everything. Okay, so I'll do the upload first, and then we start talking about what it does and all the triggers and everything. Okay, so you can see that I have just submitted a new params here. Okay, you can see that it changed the time to, yeah, so you can see it changed the time, right? And here we have the pipeline that I mentioned on the on the architecture slides. Okay, so this is the pipeline. You will see that it will start working. Okay, it will start being triggered in a few seconds, right? And once it does so, it will start deploying all the code that we want. Okay, so let me just open here. Oops. Let me just open the params so you can take a look at what we're talking about. Okay, yeah. So this is the stack that we're going to create. Okay, so let me take a look here. Let me just release a change here. Okay, so what we're going to create here, okay, the parameters we're talking about here are stack name. So I'm creating a new stack here that will be called my GSE project. I have a repository name that will be my code commit. Okay, I have the artifact that will be created. It's an S3 bucket. This is where I'm going to store my artifacts after I've built my application and I want to deploy. This is where I'm storing. This is the image that I'm using to create my code or to compile my code. And I have some other descriptions here as well about the build, about the project that I'm creating, about my deployment type, what are the servers that I'm going to use, what's my pipeline name. So I can set up everything I want here, okay? And all this information was set up and was created by myself. So I said, hey, this is what I want the user to tell me so I can do my work, okay? If I wanted to be more specific or if I wanted to add more information, I could create extra parameters here if I wanted to be less specific. So user can only tell me the stack name and the application name and I do everything for them so they don't have to bother about anything else. I could do that as well. Okay, so that's very flexible on what you want or what you can do. And it will build the infrastructure here. Okay, so it will create an instance that will be compiling the code. It will be starting to deploy the environment for you. Okay, so Bill, you want to start sharing here and show the mainframe side so as well?
Yeah, so let me share my screen. So while that is running, so okay. We connect to our environment. So basically, this pipeline, once it's tested and once we have everything ready, what's gonna happen? It will allocate some data sets for us here, called my user ID, and this will be the high-level qualifier. So for now, there is no data set. It will run our playbooks and it will create and do the upload of the data set that were already tested there. So just for you to see the playbook, it's very simple one for that. So I will just open here. So this is the application that we have there. So we have some input data sets, some COBOL, some things for kicks, for JCL, for procs, and we have a playbook there that will be used. It contains what is the high-level qualifier that we are going to use. So for now, for this demo, we are having this as a variable here. it's hard coded on this playbook, but let's suppose you are sharing this infrastructure with other members of your team. So you can pass in the command of the pipeline that is triggering Ansible, you can pass the high-level qualifier. So let's say in each of your systems, should have a different high-level qualifier. So it will override this one. And we are passing the data set list that needs to be updated. So basically, we are going to map these variables with the folders we have on the code commit. And then based on this input, based on the input of the data sets that you have on your pipeline, it will take from one folder and bring it to the right PDS on the LPAR. And after that, we are going to run our playbook with the tasks using the IBM ZOS core and showing what are the actions that we need to do. For this example, we are looking to the high-level qualifier, each of the items, allocating the data sets, ensuring they are present, and then we are going to do the upload of the data sets. Here we are just taking all the uploads that are needed based on the list and uploading the full folder for there. You could be doing some customizations for that. So let's suppose you want to have specific members. If you want to have multiple loops through them, not willing to do the upload of full folders, we would be able to do that. So if you are willing to don't use this option, you can create another loop, and using the import tasks, you can have different variables for your loop. So this group of actions will be executed. Another important thing that is there for this specific playbook, we have the inventory, where all the hosts will be defined, all the information of each of our systems. So for example, we have the environment on the ZDT, we have the Z Explorer here, just as an example. And from here, it can take, okay, for this environment, this user should be used, for the other, we should use, and what are the keys that we are using to connect there. So as you see, it's a basic example. We are taking the actions that are needed for this application, but any kind of actions you need to do, you could be using Ansible for that, to connect. If you want to integrate, if you want to have API calls, something to connect, and some action to do with your kicks. So you need to map what is important. We don't have kicks here to test it, but you could have all the actions you usually do on your deploy, map them on the playbook, and have them being executed. Let me see in which step we are on the pipeline, if we should have read or not the data sets allocated. So not yet.
No, it's still running.
Back.
Yeah. So one thing that's very important to remember is that, as Bill mentioned, right? Everything that we're talking here and that Bill showed is running on the cloud side, but deploying to the mainframe. Okay, so it's not that we're moving or we're doing something different. It's just that we are actually creating a really or a real hybrid approach for both cloud and mainframe. Okay, so we've seen lots of people talking about hybrid environments and how we can extend functionalities between each world, right? But it's usually hard to see how that would work or how we would implement that. That's a real case or a real scenario where we can implement and create a shared environment between both the mainframe and cloud world. Okay, so you can see here that the pipeline for my application has completed already. So I've created the pipeline, and with that, I have created everything I need here. I have a new pipeline. Let me click on this one, and you will see that I have a source, which is the code commit that we mentioned. We have the code commit here. We're currently doing the build, okay, with the code build. So I'm actually compiling the code. I'm performing any test I want. I want to do something with my code here, I can do as well. And finally, and third step, which is starting now, is the deploy. So the deploying to the mainframe modernization and also to the actual mainframe, okay, on ZOS. So that's what it's currently doing. And let me show you here the pipeline. So I have the code commit where all my repository is and all my code is. So you see that we created the GSC my app, okay, and it has all the information I need. So how do I build my environment? I have it here. I have a YAML file that says, hey, this is what I want to do with my code. If I want to do some tests, if I want to do something, I want to package these files and ship that to my deployment side. And this is the YAML that actually controls all my build information, okay? If you take a look, you have the source code here, and you have all the files, you have your COBOL, and you have your JCL procs and everything. Okay, so let's take a look here. This is the mainframe modernization services that I'm using. So let's take a look. It already has the M2 workshop. Let me show you here. Let me show you here first. Okay, we have AppSpec that's responsible for the build, the deploy, and you see that I'm pasting or I'm deploying my code to M2 workshop and those files, okay, in those folders. So you see that I already have my folders here, and I already have my source. So CD source, if I want to take a look, I have COBOL, BMS, and everything. I have my load lib, so I can test my code, right? So I have my Ansible, so I can deploy my code here. As this is, those YAML files are exactly what Bill showed, okay? And let's see how the deploy is progressing. Okay, so it's currently progressing. Okay, it's after install, so it's already deploying the code to my mainframe. Okay, let me find here what's currently being done. Okay, so if I want to look, I can take a look here. CD logs and tail scripts. Okay, yeah, so I did a tail here, so I can take a look at my script and see what my Ansible is currently doing, right? And it's currently doing the tasks here that are sending the data sets or sending the members to the JCL, PROC, and CBL libraries. Okay, so it's currently doing this step. The only thing, Bill, I think we're using the Z13, Z12, 309 or something as a high-level qualifier. Okay, it's not the ZEC that you mentioned. So
yeah, I already see the data sets being created and the members being uploaded here.
Yeah. So you want to explain a little better? You're much better to explain what this is, the Ansible and everything.
Yeah, so after we have finished the testing, the playbook started to run here, and what we are seeing is the log from Ansible. And Ansible is doing, we are working here in a declarative way when we are talking about infrastructure as a code, where we are saying, okay, these are the desired status that I want. And for example, the first task we see here, ensuring the data sets exist on the LPAR. So it didn't exist at the first time. And this is the reason we are seeing on this log, the data set was changed. So for each of the items that were into the playbook, into the variable, we are seeing here as they are being created, we see the changed. If it's the if you are running again the tasks and we see that the data set already exists, we are just going to see, for example, a successful. If there is any kind of issue, it will also bring a fail task for you, a fail result in the end. and you don't need to worry about how to handle that. So when you are doing something manually, you need to worry to handle these conditions. You need to go and check, okay, before I try to allocate a data set, I need to check if it exists, because if it exists and I just try to allocate, I will get an error. So here you basically say it needs to exist, and Ansible takes care for you if it exists, what are the actions. If not, it doesn't do anything. And what we are doing here, we then have it created. We started to upload these members. So all the code that was on the code commit is being, after it was refreshed, after you have a merge or any action on your pipeline, Ansible will take that code, and it was already tested, so I can bring to my Alpar. And in the end, we have a job to compile this. So this is also then being compiled on the mainframe. We see here the status. When we are working with Ansible, if you need to bring this log back for you to handle, for you to evaluate the conditional code or any kind of information that you need to this log to take another decision, you also can. But this is, we are just taking the basics here and compiling them and letting them ready on both environments, on the environment of your developer for testing and also for you. So on the real one into the Alpar. And here at the end, you see this status that I've mentioned. So we had 3 tasks, of them were changed. There was no system unreachable, none fails, none was skipped or rescued or ignored. So this is just a summary of all the actions we have executed during this playbook.
Yeah, exactly. So I think that would be a good time for any questions that people might have or anything.
Does anyone have any questions, please?
Yeah. In the meanwhile, Bill, I think you can open the mainframe just to show that the data sets are there.
Yeah, just to make sure there's no trickery going on. Yeah.
Yeah, no, they are all here. Yeah, and the job you see is the same user ID. I just pressed enter and I just got the job submitted and the return code, because it's using the same user ID. I'm logged in. Here are just this basic things when they were created, located, information about them, and also the content of them. So all the data sets that we were using there just being transmitted, all the data sets that were into the pipeline, into the variables to be here.
Yeah. Exactly.
Well, I think that's it.
Yeah, so let me just share back here so we can complete the session. Okay, so yeah, okay, so that completes the demo and the presentation that we have. Okay, so we just would like you to remember to submit your feedback. That's very important for us so we can understand what went well and what we can improve, right? So do that online from the link that we have here, okay? And this session is age, okay? So please submit your feedback. That would be very much appreciated, okay? And once again, I do not have my email here, but let me add my email to the chat. Okay, yeah. So if you have any questions or if you want to discuss or ask anything, feel free to contact me via email. Okay, that shouldn't be a problem. And as well, I'm pasting my LinkedIn here. Okay, if you want to chat, talk about technology or pretty much anything, that I would be very happy to talk to you as well.
Thank you so much, Gilberto and Bill. yeah, unfortunately, the chat does disappear after this. So quick, if you're going to connect with Gilberto, grab those details.
Mhm.
And one final ask for questions. Not as ever, the slides will be available on the GSE conference website on the agenda bit, and the video will be released in a couple of weeks' time. Okay, well, Gilberto, Bill, thank you very much for your contribution. Much appreciated, making some of that stuff between cloud and on-prem mainframe a lot clearer. So thank you very much. Thanks to everyone for attending. Speak soon. Thank you.
All right. Thank you very much. Have a nice
Bye.
day.
Thanks
Bye
all.
bye.
Bye.